can't remember if I mentioned the exact dates you'll be testing, so I'll just mention them again if I already mentioned it. So final exam for this class is split into 2 parts. It's 20 questions for each part, and you'll take the first part on Tuesday next week. And then because you guys are my 3rd hour, you'll take part 2 on Wednesday, and I will not see you on Thursday. So keep that in mind. That's your timeline for when exactly you're testing. So we have today, tomorrow, Monday to go over as many of these as we can. And literally, I'm looking at the test, and it is so closely aligned. They are the same exact questions, just different numbers. Or maybe like these are more for your response, and the one on your test is more multiple choice. So like I'm really serious. And I am impressed with this class, probably the most so far today. It looks like a lot of people were actually working and like taking it seriously. So thank you for that. I'm still a little peeved from some of my students earlier, but you know, it is what it is. I'm sure some of you understand, you know, that maybe you can't come back from such a low percent, but either way, you're gonna have to do it at some point, whether it's summer school or next year. So I mean, might as well start grasping things now. All right, which, if any, would you like to see? Yes, number 3. So a particular car depreciates according to this expression. This is from, I want to say 1st semester, or actually, no, this is all from 2nd semester. But this was like early on 2nd semester. Do you guys remember what unit these types of equations were from? Like the very first one we did this semester. Those are our exponential functions. All right, so these equations, and it was something like this. It was y equals a, which was your initial amount, and then depending on whether it was growth or decay, it might have been 1 plus r, the growth rate as a decimal, times, or to the power of t for time. So that is rate as a decimal. And this is for growth. All right, over here you can see this is decay, because instead of a plus, they have a minus. And it also says depreciates, so it tells you that it's decreasing, not growing. All right, so when it says t is time in years, describe what the 6,500 means, describe what the 0.15 means. So what did we say the A represents? In this formula? It is a 6,500, but just like normal terms, the A stands for your initial amount. So if we're talking about cars depreciating, what do you think that 6,500 is? It's the initial amount of what they paid. So that's what they paid initially. All right, and then the 0.15 is your rate that it is depreciating. So you could say that it's the rate that it's depreciating. How much is it depreciating by? What would that be as a percentage? 15%. So the 0.15 is the decay rate. It's decreasing. Is the decay rate of 15%, it looks like, per year. All right, when it's in your formula, you want it as a decimal. So hopefully you guys know how to do that by now. If you're doing decimals to percent, times 100%. If you're going backwards, divide 100%. But that's what it means. It's depreciating at a rate of 15% per year. Questions on others? Number 1. All right, so then, and I know like this paper doesn't give you a lot of room. If you use a separate paper, I understand. I will look at it tomorrow too, just to kind of see where everyone's at, who's actually like serious about trying to improve their grades. All right, but number one, identify the coefficients of each term. What are coefficients? Are they numbers? Are they letters? Good, so they're the number in front of the variable. So there's no constants, it appears in here, but let's say we add one, like +7. Would 7 be a coefficient then? No, because it's not in front of a variable. 7 is a constant. I don't know if it's going to ask that. I just saw a coefficient so far, but just so you know, that's a constant if there's no variable. So then for each term, well, what's the coefficient? The number in front if it's not written. It's 1, not 0. If it was 0, then the term wouldn't be there at all. So the coefficient of this term is 1. What's the coefficient of this term? Good. Good job keeping the sign on it. What's the coefficient of this term? This one. This one. And then again, is this lonely 7 a coefficient? No, it's a constant. It's a single number. So coefficients are the numbers in front of your variable. All right. Any other? Yes, Kira? 12, you said? All right. So 12. I like these ones. So, oops, hold on. We have a graph with a parabola. I knew it would do that. I have a graph with a parabola and a line going through it, and it gives you the equations for each. But when it says like find the values of x that are solutions to that, you really don't even have to do any math for that. You just have to look at where they intersect each other. So anytime it asks like, what are the solutions to f of x equals g of x or something like that, it's just wherever the graphs intersect each other. So like they intersect here, that coordinate is -2, -3. And then where else does it intersect, if any? And it looks like it's more between 3 and 4, so I'm going to say like 3.5. And 5, it appears. 3, so I can clearly see it. We might have to estimate that one later. Like a little bit above the 5, so maybe like 5.1. I think that one should be multiple choice for you. So that's the solutions are where they intersect, but it's asking find the values of x that are solutions to that. So specifically in this case, you're looking for the x's. So it's -2 and +3.5 that are your solutions. If it said, what are the values of y that are solutions to this? Well, then it would be the y's, but it's not. So whenever they're set equal to each other, where they intersect is their solution. All right, other ones from the review. 11. All right, so find the value of c that completes the square. So this is a good one to go over because I think even though we went through all the steps before, people don't understand the part that is the actual completing the square. So initially, what we have is like something we can't really factor. So the completing the square makes it so that it's factorable. So anytime you're doing the actual completing the square, that's when you're taking half of b, squaring it, then adding to both sides. All right, that's the actual completing the square. So what is b in this situation? Good, yes, it is -24. then what would half of it be? And then what is negative 12 squared? That would be negative 12 times 2. Not. It's actually positive 144. Because you need to have those parentheses around the negative, otherwise the calculator doesn't read it right. That's what a lot of you guys missed on your topic 8 test, by the way. Was like calculation errors from not putting the parentheses. So then let me just double check, make sure I'm telling you the right thing. So that 144 is the number that completes the square. Because that's the number that you would add to both sides. So the r squared minus 24r plus the 144 is what completes the square. Because now when I actually do my factoring, it should be the same number that fits into this part of the diamond. So what multiplies to 144 and adds to negative 24? Negative 12 and negative 12. So that's why we call it completing the square. So it would be a perfect square. Make sense? All right, which other one? All right, so what is the average rate of change from x equals 1 to x equals 3? So rate of change, what's the other word we use for that? We also use the word slope to talk about rate of change. And yeah, we don't really have a slope for parabolas. Slope is more for like straight lines. But the reason why I associate the two is because they have the same formula. All right, it's y2 minus y1 over x2 minus x1. Because obviously, like the rate of change isn't going to be the same for the whole parabola. There's parts where it's increasing, there's parts where it's decreasing. It wants to know from where x is 1, which here is where x is 1, that's where it touches on the graph, to x equals 3. And that's where it touches on the x equals 3. So then write down the coordinates. This coordinate is 1, 5. And this one is 3, 9. And pick one of them to be x1, y1. And the other to be x2, y2. And then just plug it in. Make sense? So rate of change, same thing as slope. It uses the same formula. So then it's 9 minus 5 over 3 minus 1. What's 9 minus 5? What's 3 minus 1? And reduce that. What's 4 divided by 2? So my rate of change for that region of my parabola is 2. All right, other ones. Yes. 13. All right, so the first 5 terms of the sequence are these numbers. Let me just copy that number over here so it looks better. Write both the explicit and recursive forms of the sequence. So I'm starting to think that maybe I'll be nice and let you use your review sheets on your final, because this is a lot of formulas that we're expecting you to remember. And like the explicit and recursive, I don't expect students to remember. So first explicit is a sub n equals, let me look it up actually before I tell you. Okay. Okay, this one is good. All right, so your explicit will be the one that's on the top. So I'll copy it over here. A sub n equals a sub 1 plus parentheses n minus 1 times d. And then recursive, I'll fit it somewhere down here, is a sub n equals a sub n minus 1 plus d. Yeah, so some of them, the formatting is a little bit different. And then it does depend on whether it's explicit, whether it's arithmetic or geometric. So let's actually figure that out. What's the pattern between these numbers? Am I constantly adding something or am I constantly multiplying something? And what's my common difference? So we're adding 3 each time, right? So that means we do have the correct formulas here, because for the arithmetic, we call it common difference instead of common ratio. So then a sub 1, do you guys remember what that stands for? Good. It's for the first term in the sequence. So my first term in this sequence is what? 8, and then it's going to be plus, and I've seen them have it like this, and I've also seen the D be up front. It doesn't really matter, but I'm going to put it up front because I feel like that's how it will be on your test. All right, plus the common difference, which we said is what? Parentheses n minus 1, and the n can be basically for any number. All right, it's for your nth term. So here is the explicit formula for number 13. So if it asks for maybe like the 20th term, then I would just make the n 20 and solve for the 20th term. But this one just asks for the rule. So then for the recursive formula, same, it's similar. It would be a sub n equals a sub n minus 1 plus the common difference, which we said is what? 3. And then usually I also see this part added to the rule where they still identify the first term. But yeah, that's it. That one just asks for the rule. And all the differences between them, recursive is basically saying if you take the previous term and add 3 to it, you get the next term. That's literally all it's saying. All right, any others? Yes, Tirza? Number 20. All right, so sketch the 2 possible graphs that could show a function in this form. All right, so let me figure out what it's asking. It looks like a quadratic equation. I don't know why it says plus c. Let me look. All right, so this is a quadratic equation. I'm not really sure what it's trying to go for on this. I can tell you that for vertex form, it looks something like this. So f of x equals a parentheses x minus h plus k. And your vertex would be hk. And I think that's all about you really need from that. So I'm guessing you're going to have options on your test for which ones could have an equation in this format, and the K just tells you like any up or down movement. So it'll be like the same structure, it just might be moved up or down. So let me show you that on the key. Hold on, I'm gonna pull up the key. I don't know who this is. The vertex you can see is at x equals -2, but the y is different. And I guess the y could just be different based on whatever you pick for c. All right, so back to this. Keep in mind that for your vertex, like if I had to pick values for the vertex, the h is always like opposite of how it looks in the equation. So if it looks plus here, then it's actually minus for the h. All right, the k stays normal. The k can have whatever positive or negative it says on there, but the h always has the opposite sign. Because if you think about it, if h is -2, when I plug it into this formula, I get x minus a -2, which what happens to that double negative? Becomes a positive. So then if you also want to write this down, the axis of symmetry, when it's in vertex form, is x equals h. Questions? All right. So then we'll end it there. Good job.